Hello, welcome to today's webinar. We are happy to have you with us for this National Grid session, Zero Net Energy Commercial Forum. I am Connie Empress, Communications Manager here at New Buildings Institute. First, you are muted and we cannot hear you. This helps keep the background noise down so that everyone can better hear the speakers. I want to direct you to the dashboard that you should be able to see on the right-hand side of your screen. If you are having technical difficulties and cannot see the slides or hear our speakers, you can use the question pane in this dashboard to let us know, and we will help you as we go. We will take a few questions at the end of the presentation. Please ask questions in the same question pane. Please take a moment to answer the survey at the end of the webinar. We consider your input in the planning of future sessions. If you are seeking AIA credits, this survey is where you will share your AIA number for credit submission. This session is being recorded. All registrants will receive an email tomorrow with links to the recording and slides for this session. If you need a certificate of attendance for your records, it will also be part of tomorrow's follow-up. Speaking of AIA credits, learning objectives for this session are there for you to read. I'd like to pass the microphone to Kevin Rose, Senior Strategy and Policy Analyst at National Grid.
Thanks, and good afternoon, everyone, or good morning if we have some folks who aren't in the Eastern time zone here. So I wanted to first introduce myself. If you have attended these items, these webinars and events in the past, you may be familiar with my colleagues Laura Redormer and Mona Chandra. So I'm newly taking over for them and leading on our net zero energy work. So first, I'm very excited to introduce myself to you in this way. I also wanted to promote, while this is the commercial forum in winter 2020 here, you should be seeing on the screen before you now. Next week, we'll have a similar event on the residential side. So in addition to our friends at NBI providing some best practices on zero energy homes, you'll also see a really cool case study right here in Rhode Island, and it's a really great time to look at that project as they're right in the middle of construction. It's a 5-unit small housing project, affordable housing, passive house, using training as a way to train up contractors on how to build these homes for apprentice folks here in Rhode Island. So everything you could want. Take a look this time next week. And on the next slide, you'll see it doesn't stop there. We even have a virtual tour coming through a related effort 2 days after. I encourage you to attend either or both. You'll get a different flavor. We've run the virtual tour. I've seen a preview of it. It works really well, and hopefully a really attractive option for everyone cooped up at home a little bit this year, maybe missing seeing all this cool stuff in person. This virtual tour is hopefully a really great option. So again, next week, 2 opportunities to take a look at residential zero energy. So as we go to the agenda slide, I wanted to run our first poll of the day to ask us who's here. Give our presenters a chance to tailor their messaging to you. And Connie and Webley, you can let us know what the results are when it's time to wrap that up.
Sure. I can close it out at any time so we can see those results. Looks like we've gotten about everybody here, almost. All right, I'm gonna go ahead and close this. Uh-oh, share. There, you guys able to see the results? Okay.
All right, great. So just a quick agenda to set up what we're talking about today. This webinar is part of the market awareness and building interest campaign of what we're looking to do at National Grid. But we also offer support at the program level. And so through these webinars, we like to give you the latest and greatest of what our program offerings are for zero energy projects. So I'll start with that. And then of course, our shared ambition on this call, I think, is to take this from being demonstration projects to becoming mainstream. So Matt Welker will talk to us about an effort to transform the practice of architecture in a way that is holistic, firm-wide, project-based, and data-driven, and looking to achieve that 2030 challenge. And finally, let's take these principles into practice. We're going to look at a local case study, and Jesse Thompson is going to walk us through that. So on the next slide, we'll transition into National Grid's historic and coming program offerings. So over the past few years, we have run a zero energy pilot program on both our residential and commercial sectors. And you see the various aspects of the program on the slide in front of you. The takeaway message here is a pretty robust set of technical assistance and incentives working across the construction process from beginning to end. And the intent here was to learn enough and gain enough experience to offer a full-fledged program as part of National Grid's wider energy efficiency portfolio. You're hearing some new news on, or some pretty new news on this webinar, so good for you, because on the next slide you'll see, starting this January, the Zero Energy Pilot is being incorporated into our National Grid new construction program in Rhode Island. So you'll see there's not a lot of difference between the last two slides. So if you had been hearing about the Zero Energy Pilot and we're looking to take advantage of it over the past few years, rest assured, a very similar offering is available to you through our regular new construction program starting in January. And you'll see that we even have, you're among the first to hear this, we're planning for a launch event on January 28th. So save the date on that. A more formal invite will be sent around when those details are solidified. But that's the snapshot into the future that I wanted to provide, and I don't want to take any more information from our panel of great speakers. So with that, I'll turn it over to Matt.
Hi, y'all. Thank you. So my name is Matt Welker. I am the Director of Sustainable Metrics and Operations at the American Institute of Architects in Washington, D.C. And part of my job responsibility, part of my portfolio includes overseeing the 2030 commitment. So I want to start, again, in the spirit of getting to know y'all, with a quick poll around y'all's current participation and engagement with our program. So if we could pop that up.
Okay. The poll's ready. Okay, about half the people have voted. All right, I'm going to close this out in just a couple seconds here. All right. All right, there you have the results.
I love it. All right, so it looks like we have a little bit split between familiarity with the program and folks who don't know very much at all about it. So I'm going to cover some basics for the 29% who are already signatories of the program. Awesome, and thank you. But for the others, I like to start with a couple of foundational points to my presentation. So I'm going to be fairly quick. So the first is that climate change is a design issue, and the AIA recognizes that. Buildings generate about 40% of annual greenhouse gas emissions globally, and mostly that's in urban areas, although certainly not exclusively. According to Architecture 2030, a quarter of those emissions, about 11% globally, come from embodied carbon, that is the carbon emitted over the life cycle of the project, including construction and material manufacturing. Accounting for this embodied carbon portion is increasingly important. We're seeing an uptick in the number of folks who are looking into it during the design of their projects because embodied carbon is spent upfront. And so we're making changes to the 2030 commitment and our online tracking software to look more explicitly not only at operational carbon, but also factoring in embodied carbon to really acknowledge the sort of design issue piece of climate change. But the bread and butter of our program is the 3/4 of building related greenhouse gas emissions that come from building operations, which can largely be driven up or down through building efficiency measures. So the second tidbit, I'm struggling with there we are. The second tidbit, the second fact that we like to frame is that design strategies have the greatest impact on building energy use. So again, this is largely intuitive, but architects have the tools, design teams have the tools to drive down operational carbon through energy efficiency as much as 50% based on simple passive design strategies or embracing programs like Passive House, which we'll hear more about later. And through those means are able to get us further toward the energy reductions that we're looking to see as a program by reducing demand on mechanical and other devices. And so that work really starts early in design process. It really starts with integrated design teams. The third tidbit, there we are, is that while the consequences of climate change are alarming, they're not inevitable. The 2018 UN Intergovernmental Panel on Climate Change report shown here reported the need to limit global temperature change to 1.5 degrees Celsius and required, quote, rapid and far-reaching, and quote, improvements to reach net zero by 2050. The report noted that the heightened severity of weather events will cause increased loss of human life, more frequent crop failure, and more displaced people. It destabilizes governments, it increases the risk of conflicts, it hurts the global economy, and we already see it play out in how it jeopardizes human and public health through air and water conditions. But the report is also very clear that if we can stay within our carbon budget, we can mitigate the worst effects of climate change. And while estimates for the carbon budget vary, the World Resources Institute estimates it's between 570 and 770 gigatons of carbon dioxide. We're enthused by this, and we see this in the 2030 data as well, because as professionals, there's a growing coalition of folks who are committed to meeting these targets and transforming the built environment to that end, whether it looks like a net zero project or hitting our progressive targets. There are pathways to do it. We have the technologies, the skills, and the design strategies. It's looking at rapid deployment and scaling up. And so at the American Institute of Architects, we're excited that last year, a member resolution overwhelmingly passed calling for urgent and sustained climate action. We're seeing that reinforced in our programs, including the 2030 commitment. So the 2030 commitment, which is that next slide, as we heard earlier, exists to support the 2030 challenge and transform the practice of architecture in a way that's holistic, firm-wide, project-based, and data-driven. So there are two pieces to the puzzle, and I'm going to unpack those quickly. The first thing we need to understand is the 2030 challenge. The targets you see on the screen now reflect the 2030 challenge. They were established by Ed Mazria and his nonprofit Architecture 2030 back in 2006. They emphasize reductions in predicted energy use intensity, or PEUI, and decreased reliance on fossil fuels, approaching carbon neutral buildings for buildings, major developments, and major renovations by the year 2030. 3 years after Architecture 2030 introduced the 2030 challenge, the AIA in 2009 launched the 2030 commitment, which is our internal program. And the purpose of our program really is to build accountability and community around those targets, to help firms, to help architects, engineers, owners, every member of the project team make progress toward these goals and demonstrate accountability toward the targets. So participants, whom we call signatories, commit to working toward these targets largely by prioritizing energy efficiency in their projects. And these targets definitely get the attention. Every year when we issue our annual report, which usually comes out in September or August, the number that gets picked up is how far toward or against these goals are we as an industry. It's definitely where folks focus. But for me, I don't know that it's the most important piece of the puzzle. Insofar as we're committed to these goals, we're also focused on transforming practice in a way that's holistic and firm-wide. And that's where we start to look at the Sustainability Action Plan. So this diagram just shows the 5 steps that a signatory, whether they're an architecture firm or an engineering firm or a energy modeling consultant, takes after joining our program. So it begins with signing up and saying, hey, we're going to do this, we share the commitment, and then it moves into creating a sustainability action plan, then working to meet the goals, reporting that data annually, and then after 3 years or so, going back and saying, what is working for us, and updating the sustainability action plan. The reason we put the sustainability action plan in this timeline is because at its core, it's documenting a firm's approach to sustainable design and saying how they're going to meet targets, whether they're ours or ours plus some internal target that they may have. And we ask folks to do it within their first 6 months. So a lot of times we find that people join the commitment because they're already interested and engaged in sustainability. They may already have a similar document, and that's great. We encourage them to dust it off and look at it through a separate lens, because for many firms, achieving the 2030 commitment targets requires ongoing changes and evaluation of your organizational culture, your systems, and your design processes. And you'll hear a little bit more about that in Jesse's remarks as we hear about how his firm has adapted to meet the targets and be one of 27 firms to meet our 70% reduction in 2019, which is a huge accomplishment. So we've been at it for about 10 years. In that time, the program has grown from a handful of architecture firms to over 700 architecture, engineering, owners, consulting firms. The program started with architects, but it's not exclusive to architects. We certainly encourage and invite engineers and consultants to be part of the movement and the campaign and share in these common goals. At this point, many of the largest architecture and design companies in the US have already joined, and they're regularly sharing their data and improving their portfolio. But we're also seeing tremendous growth in smaller firms, especially firms working on residential. For example, as folks are embracing these targets and taking steps to improve their portfolio, sort of regardless of their size or dimension. And we think that's a really promising thing to see as we share in these goals. The other thing we know 10 years into this is that the impact that our members can have is significant. So looking at our 2019 data, which is the most recently available, we have over 2.1 billion square feet of projects reported in the US alone. This map shows the density. So the more blue cells have a higher number of projects, the more green cells have a fewer number of projects. And then the numbers within each state is showing what the overall PEY % reduction is for that state based on projects reported through the 2030 commitment. And so you're seeing really high achievements in California and Texas and New York. But year to year, we see this map fill in and get richer and richer and more blue every year. And that's a really positive sign to see. We're also seeing growth globally. So this is showing the rest of the country. In addition to the 2.1 billion square feet reported in the US last year, an additional 1.3 billion square feet were reported globally. And again, we see this map increase and fill in every year as our architects, engineers, and other partners are exporting work. In sum, these savings are pretty remarkable. In 2019 alone, the projects reported are equivalent to avoiding the same amount of carbon as sequestered by 26.4 million acres of forest in a single year. It was 20.2 million metric tons of CO2. And that in and of itself is sort of an accomplishment as we work toward reducing our carbon contribution. We're also seeing that it's possible, right? 10 years in, we know that this work can be done through looking at design strategies and deploying technologies responsibly, including passive design and passive house technology, for example. 15% of all of the reported GSF met our 70% PEY reduction target last year, which is still a difficult target to reach. And so that's a fairly huge accomplishment. And beyond that, we saw 194 whole building projects that are reporting being zero net energy or 100% or greater PEY percent reduction. And it's yet to see how those play out. Certainly that's design data, which is primarily what we track. But I think it tells a really positive story about the growth that we're seeing and the movement building that we're seeing around reaching our zero energy and carbon neutral 2030 goals. The other piece I want to nugget, I mentioned it earlier, is that 27 firms this year did meet the target, including Kaplan Thompson. So I'm really excited to get into sort of their design process and strategy. We'll be featuring them and other firms who met the target in some upcoming webinars that AIA is hosting. You can learn more about those and other events and programs that we do throughout the year by visiting ai.org/2030 commitment or emailing my team at 2030commitment@ai.org. Again, lots of resources and webinars throughout the year to help make participating in the program and meeting the targets easier. That includes some new guidance we have coming up around developing your sustainability action plan and even just getting started with the program and introducing program change to your firm. So please reach out, and I look forward to hearing more from Jesse about how his firm has done it.
Jesse, if you want, there you go.
All right, so am I on? Okay. Well, thanks, Matt. That was great to have an overview. And we've been members of, as a signatory for a while, and as a group who, essentially made the goal the last 2 years. It's been a really interesting journey. It's definitely a bit of a head spinner when you get into putting all your data in. But I think it's been really valuable. We are an architecture company in Portland, Maine. Here we are. This is our crew right now. And I think one interesting thing is that we're a little odd in that we do all our energy modeling in-house. And so most of the people here have done energy modeling of some form. It's not actually sort of handed off in our group for a lot of our projects. And that's, I think, been one of the funny ways, the secrets of our success on some of these avenues because of the sectors we work in. But here's where we are, Portland, Maine. We were the first Portland, so we city by the ocean up in Maine. And it's sort of traditional for we're talking about net zero energy, fossil fuel use. Here's our climate change peril. Here is one of our beloved oyster bars, which now this is a king tide. This is not this is just a storm and a high tide, and this didn't happen literally 20 years ago. When I got to downtown Portland, and now this is our little peril. But why are we all in this room? We're here to try to avoid the peril. So here's a nice chart which puts, I think, what Matt was talking about in focus of these ideas that we are trying for these 70–80% reductions, and you're trying to get to zero. Zero fossil fuel use, zero carbon emissions, operational energy is the hope you're trying to pull off. And one thing, interesting. And so what I'm going to show today are affordable housing work we've been doing, multifamily low-rise buildings in that 2 to 3 to 4 to 5 story range in the Northeast. And so an average apartment is a 69 EUI, and our goal is to get to zero. So if the average thing out there in the Northeast is a 69, that's gross energy, total energy, everything in the building all put together. In 2015, we were trying to get to 21 on EUI. In 2020, you're trying to get to 14. What I'm talking about is the way that the passive house work has influenced our work. And you can see that a passive house is about a 15 EUI building. And that's with no renewables. It's in that, it's 15, 18, something in there. And the reason why we've chased this is that it's probably the global best residential conservation program we've found. And after trying a bunch of things, and here you are, we're within striking distance of zero when you're doing a passive house. And that means that, here we are, here's the spectrum of buildings. So we've got zero as the goal on one side, and we've got, we learned recently that fast food restaurants are like 405 EUI. It's like you took everything in a building and shrunk it down to be a fossil fuel generator into one tiny little package. So don't try and fix those with solar energy. But these apartments, these 69s, we're working on really a lot. And the idea that you could be at a 15 before you add renewables means you're totally within striking distance of net zero if you do these techniques. And that's why we're here to talk about some of the lessons we've learned on the way to this. Our first passive house multifamily building, this is the greenest building in Portland, Maine. It was a passive house, and the owners had the goal of this. So it's a 4-story wood frame, low-rise building. And that success of that one led to things, a future project with that same client called us up. And what was interesting is that first project was one of those classic pilots where it's like, we want to do passive house. We want to be, this huge goals. It's really hard to pull that off. And the same client came to us with the next building and we're like, we don't want to do passive house. So that was a lot of work. And so, but we still ran the energy model, even though the client didn't ask for it. And we sort of came to some surprising ideas, which is that if we took the same techniques we'd done on the last building and rolled them into this building, we were right in a passive house range of this very low 15 to 18 EUI building. And we never really told the client we were doing it. We just put it into the construction docs and built it. And, it's to the client, they got a really nice, these are affordable housing. I mean, full on tax credit, 40% AMI, 60% AMI buildings. They got a beautiful building that works well, that has low bills. And here's this chart again. These buildings here in their calculated projected EUI, of course, not maybe actual, these were 18 EUI buildings. They're really, really within range of this, this thing we realized. And so we sort of caught on that we'd figured out some techniques. And then the last years for us have been this big push. We sort of in the office, we started calling it like from rendering to reality, where 3 years ago, this was a rendering for an RFP in the city of Portland to produce workforce housing. And it was a non-subsidized workforce housing building, was what our client proposed on an old parking lot in the city. And here's the building up and running. These are apartments that are for sale. These are the least expensive house in Portland, Maine at this point. Really nice 1-bedroom apartments. And that building, we again deployed these same techniques on this building as well that I'm going to show you in a second. And that scale is going where we're working with the same client I showed you a second ago. Here's a 5-story podium building in South Portland, Maine. Building essentially a new downtown in a neighborhood that didn't have an on-street walkable neighborhood through affordable housing using passive house techniques. And here's a picture of it a few weeks ago, rising up. We're hard into framing right now. This is just this is about a month ago. And so what we had a joke in the office that we were like, this is the Northeast United States Passive House Enclosure System Package trademark we're going to show you. It's not trademarked. Anyone can use this. We're going to show you some techniques. But we were approached by a affordable housing developer in Massachusetts who was there's been a big rise in affordable housing. State agencies are starting to incentivize passive house as a path to net zero. And they are giving bonus points in their scoring rounds for the very, very competitive process to be awarded affordable housing financing. And so this company approached us to say, we want to come up with a prototype that we can deploy in multiple sites. And we can do multiple submissions, but we don't have to reinvent the wheel every time. We want to essentially come up with a prototype that we can build several times and really sort of do this at scale. And that was really intriguing to us because, as Matt said, like, we're trying to ramp up good buildings. We're trying to produce a lot of good buildings really quickly. And so this this project, the first version that's been built is in Griswold, Connecticut, and it's in Oak Tree Village. And you can see that this is the, it's got 2 phases, but 2 of these buildings built first. This is a 36-unit, 3-story wood frame building, kind of classic things that get built in communities all over the country, especially, in the Northeast. And, you're trying to, this I think was in, well, was it a car dealership? No, this was actually a nursing home that had been taken down, and when the owner bought it, it was just a vacant piece of land. But we developed a floor plan that you could work with and fit onto multiple sites, and these are very simple. This is very very tricky work. It is affordable housing. These are very simple floor plans. You have to be really rigorous and simple about your designs. It has to be very buildable. You can see these roofs have no solar on them. And that's also one of the quirks of affordable housing, where most states consider photovoltaics to be part of the construction cost, even though it's really like pre-fueling the fuel tank for 30 years. And so you don't end up with solar on these buildings quite often because it breaks through the cost caps and makes projects unaffordable in a weird way. So there's a whole policy thing that needs to change, but it'll make great solar buildings later. So here's the second version, which is in Newington, Connecticut, which would be, this would be one that's an old car dealership, but you're trying to make a town green, make a nice place to get families together, picnic area. A lot of these towns have very high car parking requirements, but slightly different tones and colors, slightly different arrangements, using different materials on it to try to build some variation town to town. But the same things are lurking in the guts of these buildings. And this first building, here it is. Here's the site from a drone. We are a month away from completion on this, a clubhouse and 2 36-unit buildings, and they have to be passive house to be awarded, to get the funding finalized. So it's very high stakes here. But this is, here we go. This very normalized construction, but with a few key differences that we've brought into this to pull this off affordably and be able to do this at scale. But just some construction shots of these projects going up. And here, I'll talk about this in a minute, but this photograph has a key detail. Like, why is there zip on the ceiling of an apartment? Like, that's a bit of an odd detail. But I'll show you in a second. And this is all about air barriers in this form of construction. So here we are, we're flying towards the finish with this building on one of the 2 buildings going up. And you can see the scale that is happening. This is the fast, cheap, and out of control joke, which that we are 144 apartments at Oak Tree Village, 108 at Cedar Point, Connecticut, 81 in Friars Court, New Hampshire, 48 in Goffstown, New Hampshire. This is 381 apartments up and built within 2 to 3 years with one company, all at passive house levels, all hitting the Architecture 2030 targets. So here it is. Here are our typical construction methods. Here's the secrets. Like, this is what we're here to teach folks, is what we've learned. This is, the diagram of these buildings is that these are slab on grade truss roof buildings, which are incredibly common in this certain scale of construction all through our country. This is the optimized way we build these light wood frame buildings. And at their core, they're a big, simple box. And we really try to approach them from an air sealing, air barrier, thermal enclosure level as a big, simple box, hiding behind the architecture of the building. And so the truss roof, the slab on grade, all these have techniques that we use. And the whole building is detailed to make that possible. You have to be able to, build a good air barrier. But we don't actually start there. What we do is, what we've caught on, and I'll show you some slides in a bit, that what really, really drives success on these buildings is really good ventilation systems. And these are mechanical ventilation systems. These are heat recovery ventilation units, energy recovery units. And we go for the absolute best efficiency we can. These are systems from people like Ventacity or Renewair, Semco, Temp-F. These are 80 to 85% efficient heat recovery units. You're maybe putting 12 apartments on a box, and then they're sort of semi-central. You might have 3 of them in a building like we just showed. And we're in the middle of a pandemic we've realized is ventilation driven, that this is an airborne pandemic. And I think it's woken a lot of people up that we don't have well ventilated buildings. We don't have buildings with good fresh air in them. And that's led to, we've abandoned. How many buildings are sitting empty across our country that we're scared to use them? And so that comes into human health at the most extreme level. But this has been true, I think, for a long, long time, is that in the multifamily sector, people have been building a lot of buildings with exhaust fans that aren't really well ventilated. They have mold problems, they have mildew problems, and there are these code loopholes, I'm going to call them, inside ASHRAE that say that this is an okay building to build. And we've become very sure that it isn't okay. It's not okay for human health. It's also not okay for energy savings. And I think we haven't really, what this has taught us is we haven't paid enough attention to just how big a problem it is. But here's what we're doing with these buildings. These buildings have ventilation lines run down the corridors that go in and out of the hallway that meet the fire code. And these are uninsulated because they're not moving hot and cold air. This is 65-degree air moving up and down the building. And it's taking all the bad air out of the bathrooms, and it's moving fresh air into every bedroom. You are not dumping it just into the living room. You are putting it into everyone's bedroom, gets fresh air supply. And because the units are so efficient, the fresh air coming in is warm, and you don't need expensive makeup heaters inside the ductwork to warm that air up, which is a further cost savings. And then for heating and cooling, what these buildings, almost invariably, these are VRF heat pump, air source heat pump buildings. They're not ground source heat pump buildings because it's so expensive for those systems. They are, and even VRFs are really kind of expensive for affordable housing. And quite often we end up in some really tough cost reduction moments where we are, we're staring at a big fancy computer controlled VRF and someone's trying to come up with a simpler way to do it. But these buildings do need cooling in almost all climates now, and especially with the weather shifting under us. Things are hotter in the Northeast than they used to be. Windows. Inside this sector, we're using very conventional triple glazed windows. These are vinyl triple glazed American Northeast builder windows. They are not European tilt turns like there's a bit of a reputation in the passive house world. We're able to get these to work with these sort of 0.25U, 0.2U overall windows. They have pretty low solar gain. We're actually much more worried about overheating in these buildings these days than we are about letting the sun in sort of a passive solar way. And we are trying to develop details that allow us to use flanged windows that are taped to the outside face of the sheathing, and that the outside face of the sheathing is the air barrier of the building. It's very simple to describe, very understandable to builders. We're not asking them to do alternative techniques. We're working within North American components, and we can get these to work inside this energy model piece. And then so finally the enclosure, it's ventilation first. Then you basically don't have very much heating or cooling in a building that's almost passive. But here's our enclosure. If we've done all those other things, these buildings have 2 inches of rigid insulation on the face of a 2x6 stud wall. This is basically a building code level building in the Northeast. And this has been the big thing we've sort of realized, is that if we do these other things really well, we don't need extra insulation. And there's a sort of perception that insulation is what you need to get to net zero. And we're seeing it's not that. Now, this is a thermally broken exterior. It is a complete contiguous package all the way around it. And that's really important. But we've got a truss roof with cellulose insulation and loose fill cellulose on the attic floor. It's really, really simple. The key though is that we have an air barrier, and that's what you saw in the photograph before, is we have gotten folks to install a hard structural air barrier on the underside of the roof truss. So where that dashed red horizontal line is, we are applying a structural material, like a zip sheathing that gets taped that you can walk in and visually inspect for holes. And we are not, spray foaming from above or hoping that a vapor barrier will do it or something like that. It's like you need something hard that slows down electricians and slows down mechanical people so they can't just cut a hole in it. And when you look up, you better see daylight and know that there's an air barrier. And this will all be hidden by drywall, but this is this, structural layer all the way around the building that's hard that you can't put your hand through. And that's what your air barrier is. And that's been a big lesson for us. But we're down to, we have very minimal spray foam in these buildings. There's very high embodied energy in spray foam. They're pretty toxic. They have really bad global warming potential. And we maybe have a little spray foam at the rim joist, but these are basically very low spray foam buildings. The air barrier is all the sheathing. It is taped sheathing, construction tape on things. Huber has helped the market enormously, but there's a lot of products that work, but it is, again, it's a hard thing on the outside that someone can visually inspect. This is how we're getting control over these enclosures. And, here's our floor slab detail. It's 3 to 4 inches of foam under the slab. For folks who might have heard about Passive House, there's sort of this talk of like foot thick foam under buildings, and that's not what we're seeing. We're seeing R16. I mean, again, that's about what code requires these days currently. These aren't and this is key to cost control, is that when the builder looks at it, it doesn't look strange to them. Everybody knows how to strip insulation out of a project. So here's the under slab air barrier, and this, just a lesson for everybody. A lot of slab crews think they're doing you a favor by trimming the air barrier nice and neat at the edge, and then you have to tell them that, like, actually, sorry, we wanted you to leave it long and floppy so that we could tape that to the building outside. Like, you thought you were doing us a favor, and instead the air barrier has a giant leak all around the edge. So, this is just a thing. You literally are trying to put photographs in our construction documents of make it look kind of like that, but you've got a really good air barrier under the building on these buildings. And so here's this talk about what our insulation levels are on these buildings. You've got maybe R12 continuous over R20, R49, or R46 in the roof. Here's code. I mean, code is really close to this. We are really in a minor variation off the building code, and probably the 2021 code. I bet we're probably there where code's going to go to. These aren't heavily insulated buildings that get these amazing performance. One critical thing is that inside these multifamily buildings is that we have field inspections and site inspections that are using things like the DOE Zero Energy Ready Home inspections, Energy Star for multifamily. There are people who are walking through inspecting it. As architects, we can't really get on site to see this that much. They have Passive House raters. And so there is a cost, and there is this absolute field inspections that requires to get these buildings done right. And EPA's Indoor Air Plus that makes sure there's good fresh air in the building and healthy homes. So here's some of the next, this is just a quick tour. Here is a building in Hudson, New Hampshire, using the same techniques that's ramping up. Here it is, this is its slab under construction. I think we are framing right now. We got the roof trusses coming soon. So quick summary, here's our lessons. You sort of have this dream that this is what you're doing as an architect and as an energy consultant and all these things, like everything's going smoothly, you're just rolling down the road. The reality is there is a lot of doing things on the fly, changing the tire while you're driving along. And we run into these really wild roadblocks. Like, it turns out there isn't a lot of common language among the construction industry, and we don't all talk the same. And someone like us who came out of maybe a world in which, the Passive House folks make certain assumptions, there's always a really aggressive cost control moment where people try to downgrade everything on the building. This is just normal. And we find ourselves in these really strange moments when, like someone's always trying to cut out the ventilation system, this high performance ventilation system, with something that maybe has 50% heat recovery. And they're doing things like, they aren't giving enough air. And we've had these funny moments where as architects were sitting at their table saying, well, you can only run the ventilation box at 60%. You can't run it at 100%. You need to like oversize it. And people like the mechanical engineer and the contractor are looking at us like, you know, like, why do you know that? Why are you saying that? And we're not sure why we know it and why we're saying it. It's like we've had to learn this through the school of hard knocks of like trying to certify these buildings that didn't work. But you know, you do become an expert in ventilation units, and you become a technical expert at things you never really hoped to do. But you have to learn other people's language to do it. The other thing we've learned is that, like any certification program, you have to basically overshoot. If you want to hit Architecture 2030, you should try to do 15 EUI buildings so that by the time you're done, you're at 20s. Passive House has a heat demand number of 4.75. We model them to be 4s because something happens during construction, something gets cost cut, there's some thermal bridge you didn't notice about, something backslides. You really have to, in design, be a little overly ambitious so that you can slide back to it. Here's the big one. I think I've talked about this several times in this quick talk, but ventilation is more important. Good ventilation is more important than insulation. And I didn't know that early in my career. I really thought good buildings were about fighting to have thick insulation. And I want to show you some data off this project. So here's the only numbers and charts and graphs we're going to have here. This is out of the energy modeling software. And in the red boxes is the building modeled as it was built. And that is 4.92 kBTU for heating. So that's a 5 EUI heating number, just heating, of the component of all the EUI that we've got here. And this is the building as designed. You'll also note down below is heating load, or size of the equipment. But so what if we'd taken this building and we didn't air seal it as well? Because Passive House is famous for good air sealing. We didn't run a blower door test. What if we did a pretty well air sealed building? And in our state, the housing authority has actually required blower doors in all multifamily buildings, which is inside their affordable housing program. And they have a standard that's pretty good. It's kind of equal to the Army Corps of Engineers. It's way better than just bad building. If we were to back off to this good standard instead of the great standard, our building goes from a 4.92 to a 9. Like just the air tightness alone, going back to maybe we were at 4.92. That one change doubles the heating demand of this building. And so, here's walking it back a little further. What if you didn't put these really nice ventilation systems in the building? What if you went to bath fans, like most apartment buildings in the US, exhaust only, no heat recovery? The heat use doubles again. You're at 20 EUI. You are no longer Architecture 2030 compliant. With heating alone, you haven't put the lights and anything else in. You've done 2 doublings by putting bath fans in and getting rid of good heat recovery ventilation. And so I think there's sort of this exercise of like, well, what if we, try to use insulation to get back to that level, the Passive House level you were in the beginning? Like, what if and we ran a test, which is we took that building, the other building, the not very well air sealed, with bath fans running, our 54 walls, this is like 12 inches of foam around this building. We've got a foot of insulation under the slab. We've got our 145 in the model in the attic. Like this is 8 feet of cellulose insulation stacked up in the attic. We can only get down to a 16. And we have piled on every bit of insulation. This is like people's dreams of code in the future. And we're only at a 16 and a half. These techniques, that got us to the 4.92, that got this super low energy use building, it was all in the great ventilation system and really good air tightness. That's what got us there, not insulation. Like, this idea that you could pile on it just blew our minds that you could stack all this insulation on this building and it didn't do as much in these kind of buildings, these larger scale, bigger than a single family house buildings. And these lessons are really applicable to anyone working in honestly any sector, even hospitals, labs, office buildings. These bigger buildings are not insulation dominated buildings, but we haven't been working on the air tightness and the ventilation well enough on these buildings either. And it's really going to be critical to change all the other big building sectors too. I mean, here's a heating load chart. This is like, you can see that these doublings happen again where we were at like half of a single family house boiler to heat this apartment building. And I think this is one of the lessons too. Air tightness is really cheap, it turns out. Like we're used to cost reduction and we're used to sitting around tough tables where you're doing things. And we've just noticed that there's never this line item which says air sealing on the charts. It's just, people air seal as part of their construction practice, and they don't necessarily know what bad air sealing is. And it's not necessarily in the cost reduction talk. And so there's this thing that we can get much, much better without raising the cost of our buildings. We're very sure about that. The other thing is, I think passive house is a weird name. It's not passive solar. If you try to passive solar an apartment building and put a ton of windows on the south side, you're going to create little ovens. So don't do that. We've been down that road before. It's passive house, not passive solar. And I think that's in the sector we work in the Northeast, it was kind of a shock to realize that passive house came out of Germany, and Germany is a really, really cloudy place. That's why it's purple. It's purple like Alaska or Seattle. But like those are the only parts of the United States that are that dark and gloomy. The Northeast United States is like northern Spain. It's a really sunny place. And so it means really good for solar panels and also really easy to overheat buildings, it turns out. And then the last slide, keep on learning. We didn't make any of this up. We learned this from going to seminars and people like the Northeast Sustainable Energy Association and the Building Energy Conference, and doing webinars like this. This is how we got where we got and where we did this. And we're not building scientists. We're not research people. We're just architects. But we went to a lot of webinars, and these are the techniques we've worked on. So that's how we've gotten within striking distance of net zero, is really, really focusing on some areas that I think we didn't really understand when we first started this journey, that it's this combination of fresh air to people, fresh air with heat recovery, and really good air tightness. And that's what we should all be really focused on every bit of the building sectors we worked on. So that's my talk. And we'll take questions now.
Thank you, Jesse. Hi, everyone. My name is Webley Bowles. I'm a project manager at New Buildings Institute. I'm going to invite both Matt and Jesse to turn on their cameras so we can do a little bit of Q&A together. So first question I have is for Matt, and thank you both for your presentations. Those were great. Matt, does AIA have examples of sustainability action plans to inspire newly committed signatories or firms?
Yeah, that's a great question. We have 140 or so sustainability action plans available in a Dropbox. The link is in the DDX help pages, which is 2030ddx.ai.org. I mentioned in my remarks, we're also working on a how-to walkthrough guide, both for firms or other organizations when they join the commitment. So what does your first year look like? What steps do you take internally, as well as another guide to go deeper into the sustainability action plans and get at what will work for your firm.
Great.
And Matt, I'll say one thing, anything that worked for us was we've seen a lot of companies that have sort of a sustainability officer, and there's one lonely person whose job is to kind of walk around desk to desk and like beg people to do better. And it's a really tough role. And we have had better success by sort of spreading it out in a group of teams and having people work together. And especially the more junior people who then have to go up to their project managers and say like, well, what's the EUI in this? And the project manager's like, I don't know. And then they've got to go back and scramble. And then the junior person says, we need to do these energy models earlier. We keep waiting till April to do our submission and it's hell. So can we do this earlier? And it pushes back. But it takes like a group of 3 or 4 of them to have the weight to push on the senior people to say, like, to come as a group and say we need to change. So that's one thing that's worked for us, is getting more people involved.
Jesse, I think your approach has been interesting, that a lot of your staff has energy modeling experience. And so they've been able to kind of progress their knowledge together, not just one person kind of pushing everybody else. Does your firm still certify most of your projects?
No, I think we don't. I mean, what's happened is this interesting thing in the affordable housing sector is that the state agencies who decided that passive house was a way to get to very low energy buildings, which they had mandates with already, they required certification. But most of our clients, and I think most people's clients, view certification with a little bit of like, it costs a lot of money, it's really hard. And so it was the authority of someone who's essentially handing out financial support to say, we'll give you financial support, but you have to do this, has meant that we're doing a lot more certification in this moment right now. And certification teaches you a lot because you have to get it right. And so you don't say, yeah, we're close. You have to really check the decimal points. And that's where some of these lessons really came out, which is, people are probing you. They're saying like, there must be a cheaper way to do this, right? And you're like, maybe, and you test things. So that's where certification has been. In this, the buildings I'm shown are going through certification rounds because of state efforts. But the private market doesn't do much of it, honestly. I think universities, we're classic universities and folks who are forced to are the folks doing it. Yeah.
So Kevin Rose, if you can unmute, I think I have a question for you, which is the question, is there a comparable program planned for Massachusetts?
Yes, great question. I meant to mention it, but we are actually mirroring our zero energy pathway in Rhode Island that I talked about at the beginning of this talk after a new program that actually launched a few months ago in Massachusetts. So they're actually a couple months ahead of us there. All that is to say, you can check out the MassSave website for all of the pertinent information of the 4 new construction pathways that are available under that program. You're looking for pathway number 1, zero energy. And in addition, the program administrators are looking to not just align across Massachusetts and Rhode Island. I think you'll see soon that Connecticut and New Hampshire will also soon be coming into the fold. So if your company, firm, what have you, operates across all those state lines, you should hopefully be seeing more alignment in the zero energy program space going forward.
That's great to hear that there's more alignment coming, which leads into the next question for you, Matt. Are there public agencies that are providing points or otherwise encouraging firms to have the 2030 commitment similar to certification programs that we're seeing for specific projects?
I would say that we're seeing an uptick, an increased interest. I'm not sure that there are many that are formally doing it, but I think part of the appeal of the program is that firms or participant signatories are being asked to look across their organization at how they're replicating these. And so if you're investing in the program, it's not investing in a one-off project. For example, it's investing in this culture of continuous learning that you can then roll forward to. And I think Jesse showed that, right? How they took lessons as they've iteratively learned and applied them to their projects and then moved it forward into other projects with clients to deliver, this an incredible number of affordable housing units that are super efficient in a short time frame. So we're seeing definitely increased interest in that because of that effective component of our program.
All right. Jesse, did you want to follow up on that?
No, I think Matt's got it right. I mean, that's, I think, what every architect, designer, builder tries to do is they try to take the lesson they learned in the last one and move it forward. And, this is just like anything else. We're all just trying to sort of slingshot each other and move, accelerate and jump.
All right, we have time for one more question. So this question is for you, Jesse. What are the conditions that make Passive House either easier or harder in the Northeast?
I mean, one thing in the Northeast is we have pretty high energy costs. So, in some of the southern states and the central states, the coal states, like energy costs are so low again that the cost benefits are lower. But if you're in Connecticut, you're paying 20, 25 cents a kilowatt hour for electricity already. And, where you're at a point where solar is now cheaper than your retail rate. And Passive House efficiency has huge leverages. So, and the other piece is it's cold here. So the cold helps, like it is a place that if you go really down south, it's, again, you're cooling dominated, your other things like that. So that helps. And there's just also a culture of frugality in the Northeast, like where the cheap Yankee is a real thing. So I think that's where these programs, these conservation-minded programs do have a good foothold in there. But it also takes a community of people learning. And that's where I showed those slides. Like we started going to conferences and there were people who had been working since the 80s on these things. And I was like, oh, okay, we'll learn from you. And that's not true of all parts of the country. There aren't as deep, the early green pioneers aren't out there as much as in the Northeast. So I think that's been an advantage in the Northeast we've seen.
Yeah, Jesse, I think your point about having a community around this is really important. I think you're showing that through your firm's work. And if I can just take a moment and recommend next week, same time, we have the National Grid Zero Energy Residential Forum, which is another great place to learn more about zero energy, specifically in residential. Kevin talked about this at the top, and we're really excited about this webinar. So I want to thank Kevin, Matt, and Jesse for your presentation today. Please do take the survey at the end of once this closes out. And if you have any additional questions, you can send them our way. Thank you, everyone.
Thanks, everybody.